we're going to take all of Earth's water and pour it on the sun. Maybe that'll cool things down a bit. But is this even possible? Why is getting to the sun so difficult? And once we drench the sun, what would happen to life on Earth? Okay, let's be real. Things are getting a lot steamier on our blue marble, so maybe instead of getting rid of fossil fuels, we can just turn the sun's thermostat down. And this is how you're going to do it, by taking all the water on Earth and pouring it on top of the sun. Kind of like the Ice Bucket Challenge, but more of a cosmic scale. Maybe that'll make the sun a little cooler. The first thing we need to figure out is how much water there is on Earth. 71% of the planet's surface is covered in water, which is about 1.3 billion cubic kilometers worth. That's 554 trillion Olympic-sized swimming pools. Safe to say, that's a lot of water. Okay, so now you've got a handle on some of the awesome power of the sun and the enormous water resources on Earth. It's time to get started. To make this happen, you're going to have to drain the oceans. They make up 97% of Earth's water. And you're not going to bother with starships and tanker trucks or even a hose. You're going to build a portal from the Earth to the sun. Let's fast forward how we get to this technology and start building. We start at the deepest spot in the ocean, Challenger Deep, 11 kilometers below sea level. It's situated in the Mariana Trench. It's pretty hard to construct anything down there. The water pressure is intense. It's more than 1,000 times the pressure at sea level. So we'll just make a portal that's 10 meters wide. But with a portal this size, it's going to take hundreds of thousands of years to drain the ocean. At this rate, the water level will drop by less than 1 centimeter per day. Okay, so let's make this hole wider, or dig a few more portals and arrange them at different spots over the sun. Right, now all the water from Earth's oceans is draining out and getting poured over our star. You get a new readout from the Parker probe. What's happening 150 million kilometers away? Not much. So, what is the Parker probe getting this right? All that water you drained out, all of it, vaporized as it got closer to the sun. The extra hydrogen increased the sun's mass. But even now, with all the water from all the oceans on Earth, the sun's mass has increased just a tiny, tiny amount. You've used up all the water in the oceans for this experiment. Our blue marble is looking pretty brown. What if you threw a ball of water the size of the sun at our sun? What would happen then? I know, that sounds nearly impossible. Where would you get a sun-sized ball of water from anyway? Well, I'm not sure. There's definitely not that much water, even if we collected all the H2O in our solar system, because the sun has 99.8% of the solar system's mass. But let's assume that somehow we got this massive ball of water together. Before we get to the sun's reaction, let's look at this giant ball of water. It contains about 1 billion times all the water that's currently on Earth. I mean, that was on Earth before you drained it away. Since water is in contact with space, something weird happens on the surface. In the vacuum of space, there's zero pressure, so the water boils, becoming water vapor. But then, because the temperature is so low, the water vapor freezes almost immediately into ice crystals. If you look at this big ball of water in the sky, there'll be a huge vapor cloud around it as this evaporation and freezing happens. A ball of water this big will also exert a huge amount of pressure on its core. As a result of this intense gravitational pressure, it'll begin to collapse in on itself. And as the pressure in the center increases, the temperature will rise. Under high pressure and high temperature, water molecules in the core might start moving very fast and breaking apart into hydrogen and oxygen molecules. As the hydrogens slam together, they fuse to form helium, releasing energy in the process. And the release of energy further increases the temperature and speeds up the fusion process. Finally, this giant water ball itself becomes a sun, powered by nuclear fusion in its core. Great, I always wanted to have two suns. But another thing might happen. the pressure inside the water ball, though very high, might not be sufficient to start the fusion process, so the ball could become a brown dwarf, which is a failed star. What would happen to our sun? Well, if this giant water ball were right next to our sun, then it may have finally met its match. This water ball would have a mass much greater than the sun, because it's the same size but made of water, and water is much denser than hydrogen. The sun will spiral into this huge water twin and get stretched out in the process. This stretching out of the sun could disrupt the core where all the hydrogen fusion takes place. If the pressure drops, this could slow the fusion process down for a while, but as the two suns come together, it could speed back up, creating an even stronger and hotter sun. So, no, you can't eliminate the sun with water.